Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about all types of data types in SQL and how to define a schema or a structure in SQL. Well, we will start with the basic data type, then go to the date and timestamp data type, then we will see some user defined data type, the domain and the type creation data type, and finally we will create the schemas using the create table command. First, we will discuss about the basic data types introduced in SQL. The basic data types consisting of the int, numeric, float, char, varchar, and this. So these are some of the basic data types that is used in SQL. And we have described it earlier in the relational model or as the first part of the DBMS. Now we will move to some more precise that the SQL has particularly used is the date time based data types. So first is the date data type. The DATE date data type referred to the current date of the system date, or the current date is prescribed if we use the date that has a predefined format. So the date data type consists of the year, that is a 4-digit year, the month, and the date of the month, say for 5, 7, and 9, 22 like this. So this is the basic structure of a date data type. Next comes with the time data type. Time will give us the time of that particular date or the current time of what the system we are using now. So the time has also got a predefined format and it looks like. So the time data type looks like the hour, minute, and second format. Even there is a more precise data type that is time with time zone. The time with time zone data type gives us not only the time but also the time zone that which the time is lying. Say for India there will be a different time and for America there will be a different time. So the time zone is mentioned for the time. There is another more data type known as timestamp. The timestamp data type allows the date and time to be combined into one, and that has got more than one predefined formats. So this is basically a look of the timestamp that consists of the date and then the time according to the time zone. So the time T will consider this one, the date D will consider this one, and the timestamp TS will consider this one. So these are the date and time data types that we use in SQL. Next comes with the default value. Say in the create table value or the create table of schema, we have used a default value. Default value means if the value is not inserted by the user, there will be by default the value that we mention while mentioning it in the schema definition of the particular relation. And it looks like. So when we execute the schema definition, we will have an ID, name, department, and total credit. If not inserted, will be considered as 0. Now, if I put an insert values into command of the student relation and has got S01, Anish, and department physics, then also it will be printed 0 with the tuple when we put it in the relation. So in this way, we can make a default value for any of the attributes or all of the attributes in a relation. Next, we will create an index on a relation. Sometimes we want to fetch only a portion of a long relation based on some conditions. Now the index will make it help us to do it more precisely. If I create an index on a relation based on a particular attribute, that means we will sort it down on the all relation above this attribute and create the index and take it in the first of the relation. Say suppose the student relation that we have now created, we can create an index on this like so basically we are mentioning here that ID is the attribute on which we want to create the index. Student is the relation that we are referring to the index, and the index name is student in, which will consist of all the IDs and then refer it to the index according to the IDs. See on the index on our book we have the page numbers that we need to find. If we want to go to chapter 6 that starts with page 81, we can have the information on the index. Same goes with here, we will have all the information about the IDs, and if I go to one number S05, then we can directly have the information of the tuple and the ID S05. So in this way, index makes us very easy to get only a part of the relation, or say a tuple or a number of tuples from a relation. So this way we can create a relation and then create an index on it and then use the index name to actually make precise use of the relation. Now there are some large object types that is supported by SQL 2. And the large object size are CLOP and BLOB. The CLOP stands for the character large object bytes and the BLOB stands for the binary large object bytes. Say we have a very big name or very big value for an attribute that consists of a character or consists of a binary values. So we can use CLOP and BLOB other than using varchar, which will not support this much big values. So these are supported by the system only by SQL 9090 standard, which will provide this CLOB and BLOB data part. So we can even attach an image or a movie to an SQL, that the database part, and have a book review which is a shorter one that in a character large object byte which consists up to KBs, and an image and movie which will be considered as binary file as blob with MBs and GBs. So in this way we can use the large object data types to be stored in the SQL or in the database and fetch that values on based on some conditions from the database. As part of the SQL system defined data types, these are all, that is a basic data type, data number data types, after that large object data types and index on data types. Now we will move to the next part, that is the user defined data types. So there are mainly two user defined data types. One is of distinct type, another is of structured data type. The structured data type is basically consisting of various var predicates having group by select statement, and then it is used as a data type. We will not discuss it here, we will discuss in our later videos. Today we are more concerned with the distinct data type. The distinct data type is the basic user-defined data type that we will define for our use. Say for an example that an instructor name also have a data type varchar 20 and a student name also have a data type varchar 20. Now if I copy an instructor name to a student name, it will be copied without any error. But the error lies in the logical level. A student cannot be an instructor. Let us describe more precisely. Say that a size of a body will be compounded in pounds and that of the money is compounded in dollars. Now the dollar is also a numeric value, the pound is also a numeric value. Now, if I assign that a monetary value is calculated with the pound, which is a numeric value, it will be a logical error level. So the user-defined data type basically deal with the logical error level. Now the logical error level gives us that to define each of the data type precisely with the user-defined name. So that comes with the data type consolation, that is distinct data type. So we will see that how to define the distinct data types and use it inside a table creation. See, I have used the create type clause to actually define the user defined data types. I have made two numeric data types, that is dollars and pounds, as the basic data type is built on numeric data type. See, the use of the final keyword is not being mentioned here because it is kept from some special purpose, but the SQL 1990 standard used this final keyword. That is why I mention it. Other than that, some SQL standards also omit the use of final in the use of the user defined data type. So back to the create type. Create type is the numeric data type that is based on, and the name given to is dollars and pounds. So these are the data type that we have created by default. Now we will use these data types in our creation of table. See, here I have created a relation department with the department name and building as to basic data types, but the budget with the dollar data type and the meals with the pound data type. So the user defined data type is basically built on the basic data types, but with a precise meaning that the budget cannot be checked with pound because it is of a monetary dealing and it is of a way dealing. Now the problem lies that if I want to update the fields like this, see the budget I have created with a numeric 12,2, that is a numeric data type with consisting decimal points. Now I have added it with an integer constant 20. So it will give me an error because the budget data type is not matching with the integer constant data type. So we need to cast it to another one to make it match with the data type and get my work done. So by casting, that is meant by converting the data type of the original to some other domain of data type that we are mentioning here, integer. So casting means converting or explicitly changing the data type of one user defined data type to the basic data type of another domain. So casting is also very important when we perform another operation on a user defined data type. Now, if I want to modify the user defined data type, we can do this just like the other DDLs with the alter type or the drop type commands. So the alter type and drop type will make me use that I want to delete an operation or the data type other than I want to modify the user defined data type that I have made. Now we will create some complex month to see with an example. See, here I have created a domain, not a data type, that is $. So the $, and dollar is basically of two different. That dollar was a user defined data type of type create command, and here I have used the create domain clause to create the $, as the numeric 12,2 but with addition we can see one constraint here, that is not null. So we can say that the main difference between a data type user-defined and an user-defined domain is that we can make a complex query or a complex statement to be a part of the domain, and also a check constraint as a part of the domain, but not in the case of user-defined data type. As we are defining a user-defined data type, we cannot put any complex statement, just the basic data types, or cannot use any check constraints to be a part of the domain. And the second most difference is that the domain is not strongly typed. That means if it is moved to another domain of that compatible matched data type, then it can be done so. So that the numeric 12,2 and numeric 8,2 comes from the same domain, so it can be converted otherwise other than being an error. But for a user-defined data type, we need to modify it explicitly. Other than that, it will cause an error, so it is strongly typed data type. Now we will see some domain creation, how to create with a query or a subquery or some complex statements. Say we are creating a domain. Say the domain is of an yearly salary named domain, which is a numeric 8,2 data type basic with the constraint salary value test, that is testing that the value should be greater than $29,000. So we are actually having a constant naming also here, which is also a key added feature, that is the use keyword constraint, after that the name of the constraint, or you can directly write the check after the numeric. So it is always better to give constant name, because the drop constraint will be easier in this way. Other than that, you need to find out what are the system defined constraint name of that constraint to drop actually the constraint. But if we have defined the constraint name here, so we can directly drop the constraint by the constraint name, same as the domain name, same as the user defined type name. So this is an example how to create a domain using a check constraint. Now we will see and create a domain using a complex constraint. See, here we are using a complex constraint of a set membership, that a set is given here to actually check the value. So we can even use a set inside a check constraint of creating a domain. Now comes with the schema part. So when we are creating a schema, we have created with several times with the create table command, that is create table name specified by the attribute name space the data type. Now we will see the extension of the create table. Say I want to create a table schema just like the table schema of another relation or table. So we can do this like, so if I want to create a table named table with the like command like the table 1, so we can create the table like the table 1, and it will consist of all the data structure, all the attributes and their data types copied to this schema of the new table. So an example is, so here we can see we are creating a table temp instructor. Like keyword will actually copy all the structure of the instructor relation in this one. We can even create a table with the data of all the values of a relation. Let's see that how to do that. So we are creating a table new as the query result from select start, that is selecting all the tuples from the instructor table where the department is music. Now this with data specifies that the create table will be created not only with the existing structure but all the values of the data that are the tuples and records of the relation instructor. Now if we omit this with data command, then only the table structure will be copied to create the new table, not the data. So that is all for the creation of table and schemas definition. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.